तो भाई सबसे पहले कौन सा सवाल कराना है? Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video, I'm going to solve a question from O-Level Additional Mathematics 4037, October-November 2021, paper 2, variant 3. Question number is 5. The topic is trigonometric identities and equations. So the requirement of part A is to show that 1 over cosec x minus 1 plus 1 over cosec x plus 1 equals to 2 tan x multiplied by sec x. All right, so the first thing what I can do is I will express these two fractions as one single fraction, so that one single fraction would have a denominator of cosec x minus 1 multiplied by cosec x plus 1. And the numerator for this single fraction would be 1 multiplied by cosec x plus 1 plus 1 multiplied by cosec x minus 1. As simple as that. Now, as we know that in the numerator, we can write cosec x plus 1 plus cosec x minus 1. And the denominator is in the form of a minus b multiplied by a plus b. It is a factorized form. So it can be expanded into a square minus b square, where a would be cosec x and b would be 1. And as we know that in the numerator, this 1 and minus 1 is cancelled out. So therefore, in the numerator, you are left with 2 multiplied by cosec x, and in the denominator, you have cosec square x minus 1. So far, we have achieved this thing. Now, as we know the fact that a basic trigonometric identity 1 plus cot square theta equals cosec square theta. This is also given to you in the formula sheet. So if I make cot square theta the subject of the identity, so cot square theta would be exactly equals to cosec square theta minus 1. So this means that in place of cosec square x minus 1, I can exactly write cot square x. As simple as that. So 2 multiplied by cosec x upon cot square x. Okay, so far we have achieved this thing. Now, what I'm going to do is I will rewrite it like this: 2 multiplied by 1 over cot square x multiplied by cosec x. This is exactly the same thing which we have achieved in the earlier working. So in place of 1 over cot square x, I can also write tan square x, isn't it? But I can also write sine square x over cos square x. So instead of writing tan square x, I will write sine square x over cos square x. So 2 multiplied by sine square x over cos square x, and then multiplied by cosec x, which means 1 over sine x. So as we can see that 1 sine x is cancelled out and 1 sine x is cancelled out. So in the numerator, you have 2 multiplied by sine x, and in the denominator, you have cos square x. Now, what I can do, I can rewrite this fraction like this as well: 2 multiplied by sine x over cos x multiplied by 1 over cos x. And in place of sine x over cos x, I can write tan x. So 2 multiplied by tan x, and in place of 1 over cos x, I can write sec x. So in this way, we have actually proved our trigonometric identity. Now we have the next part. Okay, so in part B, hence solve the equation 1 over cosec x minus 1 plus 1 over cosec x plus 1 is equals to 5 cosec x, and the interval for x is greater than 0, less than 360 degrees. All right, so the first thing, in place of these two fractions, we can exactly write 2 tan x multiplied by sec x. This is basically the identity which we have proved in part A. So 2 tan x multiplied by sec x is equals to 5 cosec x. Now we need to solve this equation. So in place of 2 tan x, I'm going to write 2 sin x over cos x. And in place of sec x, I'm going to write 1 over cos x. And this will be equals to 5 divided by sin x. So this is 2 sin x divided by cos square x equals 5 over sin x. Now, after we do the cross multiplication, we are left with 2 sin square x equals 5 cos square x. Now here, what I'm going to do is make sin square x over cos square x the subject of the equation. So I can use another trigonometric identity here. Okay, so making sin square x over cos square x the subject of the equation. And this will be exactly equals to 5 over 2, such that when you cross multiply them, you will exactly get 2 sin square x is equals to 5 cos square x. Now, in place of sin square x over cos square x, I can write tan square x, and this is equals to 5 over 2. Therefore, tan x is equals to plus minus under root of 5 over 2. So far, we have achieved this thing. We just need to solve this equation now, and the interval is 0 till 360 degrees. So I'm going to just erase this working to make some space on the same page. We need to solve this equation. Tan x is equals to plus minus under root of 5 over 2. So in order to find the basic angle alpha, we always ignore the negative sign. So alpha is equals to tan inverse under root of 5 over 2. So, and since you know that the basic angle alpha is an acute angle, therefore, whenever you are finding the basic angle, you will always ignore the negative sign. So tan inverse under root of 2.5, this is 57.69. The basic angle alpha is 57.69 degrees. But first I'm considering the positive value of tan x, because there are two possible values of tan x. One is under root of 2.5 and the other one is minus under root of 2.5. So first I'm considering the positive value of tan x, and as we know the fact that tan x is positive in the first quadrant and the third quadrant. So what we are going to do, we are going to make the slant lines in the first quadrant and the third quadrant respectively. And the basic angle alpha always lies between the slant line and the horizontal axis. So 57.69 over here and 57.69 over here. So one value of x would be 57.69, but we need to, by default requirement, whenever you are giving your answers in degrees, whenever you are giving your angles in degrees, so by default requirement is to give correct to one decimal place until and unless some other accuracy is stated. Okay, so one value of x would be 57.7 degrees. And then we have 180 plus 57.69. So x equals 180 plus 57.69, which is supposed to be 237.7 correct to one decimal place. Okay, so far we have achieved these two values of x. Now we will consider the negative value of tan x. Okay, let me just make some space on this page. Now we are going to solve this equation. Tan x is equals to minus under root of 2.5. So as we know that the basic angle would be same. Alpha is how much? 57.69 degrees. All right. But in this case, since we are considering the negative value of tan x, and as we know the fact that tan x is positive in the first quadrant and the third quadrant. So this means that 10x is negative in the second quadrant and the fourth quadrant. So we are going to make the slant lines respectively over here in the second quadrant and the fourth quadrant. But the basic angle alpha always lies between the slant line and the horizontal axis, always between the slant line and the horizontal axis. So 57.69 over here and 57.69 over here. So in this case, the values of x would be, one would be 180 minus 57.69 and the other one would be 360 minus 57.69. So basically, the angles which we are going to measure, the angles which will be our final answers will be those angles which are from the positive horizontal axis till the slant lines. Because in this case, we are dealing with a range of x where all angles are supposed to be positive. So we are going in anti-clockwise direction. If the angles, the requirement of angles is negative, so we need to go in clockwise directions as well. But in this case, we will go only in anti-clockwise directions. So 180 minus 57.69, this is 122.3, correct to one decimal place. And the other one is 360 minus 57.69, so correct to one decimal place, this is 302.3. Therefore, altogether you have 4 values of x. So just write them in ascending order. So x is equals to 57.7 degrees. Then x equals 122.3. Then x equals 237.7. And then finally, x equals 302.3. As simple as that. This was your part B for 4 marks and part A for 4 marks. Thanks for watching.